All right, the third section of Pre-Calculus 5.3, still solving equations. This time we're going to go over how to solve equations with substitution. I just have an example here of something that I'm going to go over later in these notes. X equals 5, we're going to rewrite that as a new equation by manipulating each side of the equation using properties or operations. Only do one step. For example, if I have x equals 5 and I multiply both sides by 2, I will then have 2x equals 10. If I solve that equation, I divide by 2 and I get x equals 5. It's exactly the same as the original. I could do something different. I could, I don't know, add 15 to both sides. So if I add 15 to both sides, I will have x plus 15 equals 20. To solve that equation, we would subtract 15 from both sides, and we would get x equals 5. Again, matches the original equation. So why am I doing this? What if we square both sides? If I square both sides, I'm going to get x squared equals 25. To solve that for x, I need to square root both sides. But if I square root both sides, the rule is plus minus. So for this one, I get x equals plus minus 5. I get two answers. The original question is only positive 5. So one of these is an extraneous solution. Extra. Oh, you. I can't remember how to spell that word. I think that's how I spell it. Extraneous solution, which means as soon as I squared both sides, there was only one x. There was only x to the first power in the original equation. But when I squared both sides, I gave it two answers. And because it has two answers, one of them really wasn't a solution in the original equation. So this is one thing that I just wanted to show you so that you've seen it with something really easy to understand, so that when we do it with trigonometry, you can go back and be like, okay, I see why there's extra solutions. That's not going to happen on every question. That's just going to happen on, like, I think one of them. All right. So we are going to rewrite as a single trigonometric function and solve for all the angles between 0 and 2 pi. The first one, we've got 9 minus 12 sine x equals 4 cosine squared x. So to rewrite this as a single trigonometric function, I'm going to use cosine squared x and change that into 1 minus sine squared x. Those are equivalent, so I'm using substitution for one of those fundamental trigonometric identities. I'm going to rewrite this. And since there is a squared and a regular x, I'm going to put it all on one side. I'm going to subtract 4 and add sine x, or 4 sine x squared. Sine squared x, sorry, I'm saying it wrong. And then I'm going to try to factor this. Try 4 sine x and sine x. No, that's not what I'm going to try. I'm going to try 2 and 2. Two sine x, and 2 sine x both have minuses. One will be 5, one will be 1. And then when I double check that, this gives me minus 10. Oops, that gives me minus 2 sine x. The middle one gives me minus 10. 2 sine x, or 2 sine x. And then this one would give me minus 10 sine x, which would equal that minus 12 sine x. So it is factored correctly. So now I'll set each factor equal to 0 and solve each factor. For this one, sine x equals 5/2. That's 2.5. Sine can never be bigger than 1. So this would be no solution here. When I divide by 2, I get sine x equals 1/2. That is positive at pi over 6 and 5 pi over 6. So we have 2 answers for this one. All right, the next one. We've got 2 tangent squared x minus 3 secant x plus 3 equals 0. Okay. I don't have the tangent squared, secant squared, Pythagorean identity memorized, but I can get it really fast because I want to replace tangent squared with secant. I won't be able to replace secant and make it into tangent because they have to be squared to replace them with that identity. So I'm going to write down cosine squared x plus sine squared x equals 1, and then I either need to divide by sine or I need to divide by cosine. Well, since this one is tangent, I know that is sine over cosine. I'm going to divide by cosine so that I will end up having a sine over cosine in my equation here. So that gives me 1 plus tangent squared x equals secant squared. And if I solve that so it says tangent squared, then I get secant squared x minus 1. So this is what tangent squared equals. So I have 2 secant squared x minus 1 minus 3 secant x plus 3. So now we have all secants. 2 secant squared x minus 2 minus 3 secant x plus 3. Combine some like terms. Get 2 secant squared x minus 3 secant x and then plus 1. Okay, I'm going to try to factor that. Do 2 secant x and secant x. They're both going to be minuses. They're both going to be a 1. And if I check my factoring, I will get a minus 2 secant x. And I'll get a minus 1 secant x. And that will equal that minus 3 secant x. So I know I factored it correctly. All right, so I'm going to set each factor. Oh, well, I've changed colors. Set each factor equal to 0. Change back. Now secant x cannot equal 1/2. Secant x, when we graph it, it's like like this graph. And so it does not happen in between +1 and -1. It's outside of those. So it can never equal a half. But we could also say, well, this would be the same thing as cosine x equals 2. So there's no solution for that. All right, and then secant x equals 1 would be the same thing as cosine x equals 1. And that would only be at 0. Now, if you're unsure if you're doing these correctly, we can check them in Desmos. I don't have Desmos open yet. I'm going to open it, so it'll take an extra second. But let's see. This one was called 2 tangent squared x minus 3 secant x plus 3. 2 tangent squared x minus 3 secant x plus 3. And then the second part is that it equals 0. On this side of the equation is equal 0. So I can either graph y equals 0, or I can just look at where y equals 0. Let me change my graph so we can see where where 2 pi is. And we can see that from 0 to 2 pi, it only hits at 0. Just one answer. Oops. Please remember that you can get on Desmos and check these. If you're not sure if you're doing it correct, get on there and just kind of make yourself feel a little bit better. All right. Let me see. Okay. So this one, we're going to look at changing, let's see, cosecant into 1 over sine x. And then cotangent would be cosine x over sine x equals 1. So if we added those together, 1 plus cosine x over sine x equals 1. We could cross multiply that. And the whole time I'm doing this, I'm not giving myself the opportunity to change cosine into cotangent, or to change cotangent into sine. I said cosine, I meant cosecant or sine. Anyway, there's no way to change cosine into sine or sine into cosine unless they are squared. So I'm kind of stuck. But what I can do is I can just square both sides. All these steps that I just did, I did not really have to do any of those. I was hoping I could manipulate it in a way where I wouldn't have to square both sides, but I can't get around it. There's no way to solve like by switching sines or cosines. There's no way to do it other than squaring. So we're going to have to square both sides. If you square a binomial, that is the kind where you have to write it twice and multiply it out. Okay, I did that really fast and combined my like terms. So now at this point, I've got a cosine x and cosine squared x and a sine squared x. So I could change either the cosine or the sine. But since I have a cosine by itself, I am going to get rid of the sines. I'm going to change those sine squareds into 1 minus cosine squared x. And then I'm going to solve. Let's see, if I add cosine squared x and take away 1 from both sides, and we'll get I will get 2 cosine squared x plus 2 cosine x equals 0. And here I have a greatest common factor that I can factor out at 2 cosine x. That leaves me with a cosine x plus 1. Oops. And it's factored, so I'm going to set each factor equal to 0. 2 cosine x equals 0, and cosine x plus 1 equals 0. So cosine x equals 0, or cosine x equals -1. This one is at pi, and then this one would be at pi over 2, 3 pi over 2. But because we squared both sides, there will be extraneous solutions. This is what I was going over on that little warm-up. Because I squared both sides, there will be extraneous solutions. Or I should say solution or solutions. We must check our solutions. So what I'm talking about checking is I'm not talking about going to Desmos. I'm talking about doing it by hand. We're going to check our solutions. We're going to plug it into the original equation, which is cosecant x plus cotangent x equals 1. And we're going to check all 3 of our solutions in there. So our first solution was pi over 2. So I'm going to do cosecant of pi over 2 plus cotangent at pi over 2 has to equal 1. So the cosecant at pi over 2 would be the reciprocal of what sine is at pi over 2, which is 1. At pi over 2, cotangent is 0. And if you need to, write the order of pairs down, cotangent is x over y, so it'll be 0 over 1, that's 0. So this one works. Okay, 3 pi over 2. Cosecant at 3 pi over 2, and we're talking about down here, that's going to be -1, plus cotangent at 3 pi over 2 is also 0, and that does not equal 1. So this one is not a solution. That's extraneous. And then pi, so we're going to do cosecant pi plus cotangent pi has to equal 1. Well, cotangent at pi is undefined, so this equation cannot happen. So this would be also not a solution. So my only answer would be pi over 2. Now let's check it, because who knows, maybe I made a mistake. Cosecant x plus cotangent x. So we're looking where y equals 1, and I got pi over 2. So that's my only solution. So I did it right. I think the next 2 solutions, or the next 2 examples, are basically the same as the first couple that I did. So at this point, if you feel good about it, you can start your assignment. Otherwise, you can just continue to watch me work these out. All right, for this one, because cosine x is not squared, I'm going to change the sine into cosine. Let's see. I'm going to divide everything by -1 because I do not like to factor with a negative in front. This is almost like one that we did on the first page. All right, so I'm going to get a negative. I'm going to get a pi for this answer at -1. And then -1/2 for cosine is the second and third quadrant, and these would be pi/3s. So in the second, it would be a 2 pi/3, and then in the third, it would be 4 pi/3. And there is no reason to have extraneous solutions for this one because I did not square. So I'm just going to go ahead and assume that I did it right, unless I made some silly mistake. But I could go on Desmos just to double check my answers. 2 sine squared x plus 3 cosine x minus 3. Sine squared x plus 3 cosine x. Was it -3? I think it's -3. -3. Okay, and I'm looking between 0 . Okay, so I have something wrong. It should be 0, and I said pi. So now I need to go back and find my mistake. Oh, also it has pi/3 and 5 pi/3. I wonder if I have a sign wrong. I wonder when I divided, if I divided something wrong. Because all of those signs are in, oh, I did. I see what I did, exactly what I did. So you guys are watching me do this live. Well, not live, but you know, like I'm doing this the first time this year and I don't have memorized what to do. I'm just working it out. And you notice that I made a mistake, which is crazy because I never make mistakes. Pretty perfect. But anyway, I was able to find my mistake. It was a silly mistake. If I had done this on a test, I would definitely get partial credit. But it did kind of make all my answers wrong. Let me go back and fix all of that. All of my signs were wrong. So that's going to be +1/2, and that's going to be +1. So +1 would be at 0, and then +1/2 and +1/2 would be in the first and the fourth. So this would be pi/3 and then 5 pi/3, and then this one would be at 0. I'm glad that I went back and checked my answers on Desmos. Oops. All right, the last one. It's got 2 sine x plus cosecant x equals 0. Let's see if I can mess around with this. So you could find a common denominator, and that would be 2 sine squared x over sine x plus 1 over sine x equals 0. So I get 2 sine squared x plus 1 over sine x. And that's not going to do much for me because well, I want to make it all sines, which I did, but if I cross multiply, I'm going to lose the sign in the denominator. So I don't want to do that. So I'm going to try this a different method. I'm going to go back. There we go. I'm going to go back, and instead of making it all signs, I'm going to try that new method that I showed you about squaring both sides. See if we can do anything there. Let's see if I do 2 sine x equals negative cosecant x. So if I square both sides, what will that do for me? 4 sine squared x equals cosecant squared x. Well, that might just get me back where I was a second ago. Maybe I'll go back to what I was doing originally. As I'm, making mistakes and erasing, I probably could have solved it the first way. I was looking for a better way. I just want to show you all that it's okay to make a mistake the first time that you do this. It's okay to start over. You've got that eraser. This is what the way I was doing it before. I just didn't show that step in the middle. So I just done it. Let's see. Right here, x cannot equal what will make this 0? 0 or pi. That's something that you guys learned in Algebra 2, where if we divide by 0, it makes the whole thing undefined. So I know x cannot equal 0 or pi, and we're going to have a problem. So now I'm going to cross multiply. This is over 1. So I'm going to get 2 sine squared x plus 1 equals 0. 2 sine squared x equals negative 1. I'm going to square root both sides. Oops, no, I'm not. I lied. I'm going to divide by 2. And now I'm going to square root both sides, and I'm going to see that I'm running into another problem because it looks like that we don't have any solutions. So let's see what happens if I graph it. 2 sine x plus cosecant x. Okay, so we're looking where y equals 0. And I hope you can tell, same thing I can tell right here, is that there is no solution. That's partially why I was having trouble. So if we get to a point where we're going to get an imaginary number, then there's got to be no solution. Okay. All right, work on your assignment, your worksheet, and let me know if you have any questions. Thanks.